beginning tonight with the catcher project, we're going to begin with the catcher. Just makes sense to start with that particular one. And for all of these files that have been broken into version 0s, 1s, 2s, 3s, however many versions are needed, to start out simple and show how we can work out some basic functionality and then progressively get more efficient and more complex with our coding so that we can integrate the different pieces together. So looking at the basic catcher right now, it sets up my project and paints the background color white, kills my stroke, sets the fill color to gray, and it's now going to draw an ellipse at the coordinates of where the mouse is on screen. So when we do this and run it, we do see that now I have a circle drawing wherever the mouse is. And that's great, but the difficulty that I run into is if this catching object that I want to work with, if I want to compare its value, its data, to some other object that I have on screen, namely the drops that are going to be falling later, it would be better to have the catcher contained in its own class, because then we can compare one object's coordinates or position to a different object's position. So with that, I'm going to comment out this first version and bring out the next version. Now in the next version, what's happened is the information for the catcher has been put into a class. Our visual objects that we work with this semester, we're going to try and be somewhat consistent in our naming structures, in that we will name our methods of those objects that allow us to update their positions or update their display with the same two names of the method update and the method display. So I've created the catcher class, and inside the catcher class it has a radius, has width and height, or the width and height are its starting location, sorry. So X is at the middle, Y is at the middle, so it's vertically and horizontally centered. The update method for the catcher says set my X and Y equal to whatever the mouse X and mouse Y are. Under display, it says stroke 0, fill gray, and draw an ellipse at X, Y, and then the size specified is going to be my radius times 2. Now with this, we say catcher, new catcher, because we're instantiating the class. We populate it inside our setup. This is a good practice to get into. We define our variables, but we don't assign values to them until our setup method. So define the variable. Inside setup, actually attach the value to it. Where we say catcher equals new catcher, the 64 is going to be then the radius that we are feeding that object. So now if I run this version, well, this makes it easy to catch the objects when it's really big. If I want it to be smaller, I can say 32. I can run my project again, and now it's half as big. That makes it harder. If I decide that that's still too easy, I could knock it down again. And I could put whatever number I want in here, and this determines the radius for my catcher object. So it makes it hard, and depending on what I'm trying to catch, and this is part of figuring out the gameplay as far as how to make something engaging, interesting, and enjoyable as you play with these numbers. Do I make my catching object big, or do I make it small? Do I make the objects I'm trying to catch big or small? How fast do they move? How fast can I move? We start to build these values in to figure out how to create the experience for the user, which is really an important part. But now that we have this set up, when I make my finished project, I'm going to be able to use this catcher class, and then all I have to do is say catcher, catcher, catcher equals new catcher, and then I tell the catcher to update and display, and now the catcher will be running in my game. So if I had this class available to any other project, I could now use this catcher in any other project with those 4 lines of code, provided that project knew where to find this class. The next class that we are going to look at, or the next object, is going to be our drop. So the drop, just calling my drop D for now, and then I say D is new drop. Now I'm only creating 1 drop because if you make 1, you can make 100, you can make 1,000, you can make 10,000, because we just grow upon the lessons of our 100 object project that we just worked on previously. So with this, we have our drop class. The drop class is going to do a couple of different things. So drop has an X, Y, and it has a color, and it has a radius, and it has a speed. Now it has a Y speed. All right. Thought I changed it so it's consistent, so everything is speed Y. I'm going to do that now. So currently our drop has X, Y, it has a color, it'll have a radius, and it will have a speed Y. So right now the drop is appearing somewhere randomly on screen with Y, so it appears somewhere on the horizontal axis, but it will appear vertically above 0. It's at a negative value to begin with. Technically it's at minus 32. So it starts far enough off screen that it appears to drop onto the screen, and it has a random speed between 1 and 5, and then it gets a random color. Now the update command says, hey, if we add speed Y to it, it'll move it down. Then we are going to call check bottom. Now I'm going to just look a little bit as to what's going on here, and the Y part of the reason this is still in here is this is how it's contained in your text. We don't necessarily have to do it this way, but we certainly can, and I'll explain kind of the why of what's going on with that. But we'll watch what happens, then go back and figure out what it's actually doing. So you get to see the drop fall, and when the drop goes off screen, then it reappears up here, and then it keeps falling. So the drops will perpetually loop, similar to the different kinds of things that we've created before. So what this is doing that's a little bit different is we've looked at it. Just going to leave that one there, where we've said things along the lines of if Y is greater than height plus R times 4, that guarantees it's off screen. So if Y is greater than that, then it now sets Y equal to minus R, so it now puts it back at minus R would be minus 8, so it's now back at the top of the screen. So as it falls down the screen, when it's gotten significantly far enough off screen, it goes back to the top. So it creates that kind of looping pattern that we can see. We can modify this a little bit so it's just a little bit easier to see what's going on to further confirm this. And I'm going to just set it. It goes back to 10, and I'm going to change this value here to a negative. And then that means we should at least start it somewhere on screen. So looking at it now, you'll see that it's looping. It gets down to almost the bottom, and then it goes back almost to the top. So we can see how it's looping based on it started at 20, goes down, and when it gets to height minus 32, which would be whatever, because I didn't know what height was, I guess 400. So we could have said, typed in a number. Just make it easier to see with actual numbers. Sometimes it's easier to understand. You hard code in numbers, and then you figure out how to get more random numbers. So we can see when it gets to 360 down here, then it goes back up to 10. So it creates that looping value. If you put in your update where you code it in with numbers or using heights and widths and things like that, as was in it previously, and that's how you choose to go about it, that's great. That works just fine. But I feel compelled to explain what is going on with the other version, because the other version is a little bit more flexible as it's contained in the book. And now what this talks about is if check bottom. So it calls the check bottom function. Check bottom gives me a value. It returns a value, true or false. So it uses the same if statement in check bottom. It says, hey, if we've gone off screen, return true, otherwise return false. So instead of just saying is y greater than 360, we're just calling the check bottom function, and if that's true, it resets it back to the top, otherwise it returns false, and then it does nothing. If you find that extra layer of complexity is not working for you, don't use the check bottom as it gets contained and presented in your book. Instead, go for something that's a little bit more concrete. Moving into intersection, the first version of intersection just has the two objects that are now moving around on screen, and when they intersect, we can see they're overlapping because they're filled with a transparent color, but that's it. We're going to modify it so that while they are intersecting each other, then they take on a different color altogether. So then we know that they're actually aware of the fact that they have collided or intersected with each other. One thing that we're not going to do is we're not going to attempt to create collisions between these different objects. So some of you may ask, it's like, oh, what happens if they bounce off each other and things like that. We're not going there because then it requires some different calculations, conservation of momentum, and it's best done then using vectors, and we don't want to go there tonight. So for now, what we're going to do is make it that when these two objects are intersecting each other, when they're touching, that they change their color. They highlight themselves. But currently, as the code is set up, we have two instances of the ball object. We create these objects so that they appear with a random size to them, minimum and maximum value, using random. So that sets their radius. They both get random speeds of -5 to 5, and then they're going to be randomly starting somewhere on screen. Thus, x and y are set to these random values. They update themselves, updating x and y with speed x and speed y, and then they check to see have they tried to go off screen. If they've tried to go off screen, we change their speed x or we change their speed y respectively when they hit the edges of the screen. This works really well until they get stuck in a corner. So if they are moving at an even x and y velocity and happen to strike the corner at the same time, so they register both a top or bottom touch at the same time as a left or right touch, then it can wreak havoc with it. So this is not a perfect system. There are a few instances where the system can go haywire, but in general it works pretty well. Gets rid of the stroke, it sets the fill to gray, and it draws them at their respective x and y coordinates. So to watch it again, the two balls are moving around on screen. Moving into version 1, the ball class stayed the same. The balls are updating, balls are displaying, but what we are doing is we are now calling an intersect function. What this intersect function does is it now is checking to see if the x and y of ball 1, the x and y of ball 2, then we send in the radius of these two objects, and we're trying to determine if that intersection has occurred. If so, we tell the balls to highlight. So we added a little bit to the ball class. Highlight changes the fill color to a yellowish tone. And we could change that to pretty much any tone we want. So we can see when they're intersecting, then they effectively are glowing yellow. So while they are overlapping, they turn yellow. So the magic is intersect is not a function that is built into the language. So what we have to do with this is we have to figure out how can we know when these two circles are overlapping. That is the trick. So understanding that when our objects, when the distance is less than the sum of the two radii, that means they're intersecting. So now we're going to look at something that performs identical, but the code I think is just a little bit easier to digest, because instead of actually sending, or if we look in version 2, I'm just going to uncomment one thing here so we can see it. So when we look at this, so if we say intersect blah, 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 and it's just kind of ugly, we can send in values. Ball 1x, ball 2y, ball 2x, ball 2y, ball 1r, ball 2r. But one thing that we can do with functions is not only can we send in numbers or strings or other items like that, but we can also send objects. So I can just have intersect be expecting a ball object. So I send two ball objects to intersect. As we work on the catcher game, we will be sending a ball object or a drop object and the catcher object. So it will say intersect catcher C drop D. That would, or however you want to phrase it, but we just change what kind of object it's expecting, and then the function works. So we'll be looking at that after spring break when we are helping to get all the pieces working properly. So this, I think, just looks a little bit cleaner of if we send the ball object to it. So it's expecting a ball object, then we just compute our distance, and then we compare distance to the sum of the two radii of the circles, and then it returns true or false, and then it tells them to change their fill color, and then it tells it to display. So when we watch it, it still does the same movements on screen. When they intersect, they turn yellow. They highlight. Now, instead of causing them to highlight or turn yellow, when the intersection occurs when we actually build the catcher project, we can make the drops disappear off screen. We can reset them so they disappear from where they were and they respawn somewhere else. We could add to a score. We could take away from a score. Perhaps you're trying to avoid touching things, and if you touch the objects, it's like trying to catch acid, and well, you don't want to do that. You'd want to run from it, unless you have like an acid-proof suit or something. But you get to figure out how it's all going to come together. So we're going to be able to take this logic of two things intersecting and highlighting, and now apply that to being able to create a situation where we have one object that's controlled by you moving around on screen, and then it's trying to intersect or to avoid intersecting or colliding with the objects that are falling on screen. Working with the timer, we have access inside processing to a command called millis, which is how many milliseconds has this program been running. So when I issue the command to processing and I say millis, I'm asking it, how long have you been running in milliseconds, thousandths of a second? And what I'm able to do is every time I ask that statement of processing, it returns a new number in milliseconds, how long the program has been running. So if we wanted to make a countdown timer, so let's say in the catcher game we want to add in a timer that counts backwards from, say, 30. So you have 30 seconds to catch as many as you can. That would be a use of the timer. So we would have to query on a regular basis and ask processing, how many milliseconds are we at? How many milliseconds are we at? How many milliseconds? It's like a kid on a road trip. Are we there yet? We get to keep asking that over and over and over. So the way this is set up right now in version 0, we have a total time 5,000, which would be the equivalent of 5 seconds. And then I set start time equal to milliseconds, which is when the program begins running. And then my draw function says elapsed time is milliseconds. So it asks again, all right, how many milliseconds now? minus start time, which was my original beginning time. So it makes that query. Where are we now versus where were we when we began? And then I do a quick comparison, and I compare how much time has passed by versus my total time, which is 5,000. So when elapsed time is greater than total time, it's going to print out a message, and then it resets start time to whatever the current time is, so that it is going to create a running loop. So if we watch this go, after 5 seconds inside my output window, I will see a message that says 5 seconds have passed, and now it changed the background color to white. After 5 more seconds, it prints out the message again. 5 more seconds, it prints it again. Now, if I never reset start time to whatever the current millisecond is, then it would not have been able to reset, and it wouldn't just keep spitting out that message every 5 seconds. Turning the timer into a class. This version now does a similar kind of thing, but I've been able to add a few extra things to it. So my timer class, I'll look at that first. The timer class has a start time and total time, same as what we just saw. Then I say timer, and when the timer is created, I tell it how much I want its total time to be. So when we create a new version of the timer, I say timer is equal to new timer, and I'm passing in what I want my end time, or how much time I want the timer to keep running for. I pass that into it. So in this instance, it's going to get a value of 2 seconds, because 5 is a little long to sit there and wait for something to happen. So 2 is a little more manageable. So total time is equal to 2,000, so 2 seconds. And then timer has a method, start, where we set start time equal to milliseconds. And timer has a isFinished method. And the isFinished method, with that we can calculate the elapsed time is equal to the current milliseconds minus the milliseconds of when the timer started. So we get to just keep calculating based on how many milliseconds total minus what was the milliseconds when the timer was started. Because the timer doesn't have to start running. I mean, it could be tied to a key click. It could be tied to a mouse press. We could start a timer when 2 objects collide on screen. We can start a timer that says wait 2 seconds, or wait a second, or wait a half second before you play a sound, or go to a new screen, or do something else. So we can use timers to do all kinds of different kinds of things as we add more interest and exciting things into your projects. But if we look at this, this is still very similar to what we just saw in the previous timer object. We say, hey, if elapsed time is greater than total time. Now in this case, this isFinished just returns a true or false, much like our intersection function did. So it returns those values. So using this, my draw loop now, or the setup, creates the new timer, tells the timer to start. Draw says, hey, if the timer's done, change the background to a new color, tell the timer to start over again. So when I run this, what I will see is every 2 seconds, the background should choose a new random color. So after 2 seconds, we get a new color, then a new color, because every 2 seconds, the timer will register as being finished. So it chooses a new background color, and then it tells the timer to start over again. So we can create this perpetual looping timer, and we're not bound by trying to change the frame rate of our project. Because if we have things animating and moving on screen, and we say, oh, I want this to happen slowly, so I set the frame rate down to 2, everything's going to be super chunky and ugly, because it'll be chug, chug, chug. So it works much better to then use a timer object in addition to then worrying about the frame rate of our playback.